Hello guys, welcome back to my channel. Today we'll be looking at the January 2021 CXE Mathematics past paper. Now it starts by saying answer all questions. So all questions are compulsory. All right, 1A part 1. It says using a calculator or otherwise calculate the exact value of 1 and 4/7 plus 2/3 minus 1 and 5/6. Now I'm going to work it without the calculator at first. All right, so one of the easier ways to deal with mixed fractions is to turn them into improper fractions. So it's easier to deal with. So 1 and 4/7, what I can do is to turn this into an improper fraction by saying 7, which is my denominator, times my whole number is 7, and I add the 4. So I'm going to have 7 plus 4, which is 11 over 7 plus 2/3 minus 6 times 1 is 6 plus 5 is 11. So I'm going to have 11 over 6. Now, I have two options here. I can choose to work this entire thing as a system because whenever working with addition or subtraction, the procedure is the same. So we can work the entire system, right? Now, because 3 can go into 6, when I'm finding an LCM, I don't need to think about 7, 3, and 6 because 3 can go into 6. So anything that 6 can go into, 3 can also go into it as well. That's a trick there to use. So you simply need to think about 6 and 7. All right, now what's the LCM for 6 and 7? Now, if you can't find it at first, what you can simply do is to multiply 7 by 6. At the end, if the answer you get is not the LCM, you can come back and break it down. Now, we know that 7 times 6 is 42. So let me put that down there. Now, 7 into 42 is 6. And 6 times my numerator, which is 11, 6 times 11 is 66. What about 3 into 42? All right. Easily, we can do it. We said 3 into 4, that's 1. And then you'd have carried a 1, which makes it 12. So you said 3 into 12 is 4. All right, so the answer is 14. And of course, you can use a calculator if you can't work it out. So 3 into 42 is 14. And 14 times my numerator, which is 2, is 28. All right, good so far. Now, 6 into 42 again is 7. And 7 times 11 is 77. All right, good so far. Once again, we're looking at the calculator work. So we can use our calculator to add 66 and 28 and subtract 77. All right, remember now, we could have actually put all of it in the calculator in the initial stages. So I'm going to have 66 plus 28 minus 77. That would give me 17 over 42. Now, can this be broken down? No. Here's the knowledge that we can use. We know that 17 is a prime number, right? Which means that if 17 can go into 42, then of course there's no other factor that can break down the two of them, right? And we know that 17 can go into 42. If you're not sure, you can also put this inside of your calculator, 17 over 42, and see what happens. Okay. I'm going to scroll down now to 1A part 2 and see what happens. It says write the value of, and notice in the square root sign you have a 3, which means it's no longer the square root, but it's the cube root as a fraction in its lowest terms. Okay, all right, how do we deal with this? Now, first we have to remember the rules that deals with converting powers from the cubic root in a fractional power. All right, let me just give you a reminder here. So if you have the nth root, n in there of a to the m, we have to remember that this can be written as a to the m over n. Very important law of indices there. So when I have the cube root of 27, 27 here is actually being raised to the first power. Whenever you don't see a power, it means that the power is 1. So you can write it as 27 raised to 1/3 all over, all right? Now, of course, my knowledge is this. You have 9 squared here. The question you probably want to ask yourself is this. what base can I get both 27 and 9 to? That's one way of looking at it, where you can use larger indices. Since the numbers are also not big, you can simply simplify both numbers and see where it goes, because you want the answer as a fraction in its lowest terms. Right? So the numbers are not that large, so I probably don't need to go the larger indices way. So I could say to myself, all right, 9 squared, which really means 9 times 9 is really 81. However, 27 raised to 1/3, I have to break that down. Now, how do I break this down? 27 can be written as 3 cubed. And once again, you could also allow your calculator to help you with this. All over 81. Now, the rule here for power, whenever you have a power raised to a power, it means that you multiply the two powers. So it means that I'm going to have to multiply the 3 here, which is a power, by the power on the outside, which is 1/3. And of course, you know that 3/3 make a whole. So I'm just going to have 3 to the 1, which I don't need to write. Once a number is raised to a power 1, you just simply write the number, and we know it's raised to a power 1. So we have 3 over 81. All right. Now, of course, this can be broken down because 3 can indeed go into 81. So I can say 3 into itself is 1. 3 into 8 is 2, which means it leaves a remainder of 2. 3 into 21 is 7. So I end up with 1 over 27 as a fraction in its lowest terms. I could have gone the method of larger indices, as I said before. Let me just quickly cut the page into 2 and show you that. If I was going larger indices, it would still remain the same concept as 27 raised to the 1/3. All right. The 9 squared could be written as 3 squared, and then of course the square that is there already, you put it on the outside. Now 27 to a base of 3 would be 3 cubed. The 1/3 that is there, you put it on the outside, and this goes over 3. You have power to power, so you multiply the two powers, so you have 3 to the 4. By larger indices, power times power in the numerator is just going to give me 3 over 3 to the 4. Now, by larger indices, you have 3 to the 1, if you want me to put the 1 there, divided by 3 to the 4. The larger indices say if the bases are the same and 3 is the base, you subtract the power. So I'm going to have 3 raised to 1 minus 4, which is 3 to the negative 3. By larger indices, you have something to a negative power. You can make the power positive by simply bringing it down. So you have 1 over 3 cubed, which is 1 over 27. All right, that would have been the answer. All right, good so far. Let's take it down to the next question. All right, let's move on to 1B. It says the thickness of a sheet of cardboard is given as 485 multiplied by 10 to the minus 2 millimeter. A construction worker uses 75 sheets of the cardboard stacked together to insulate a wall. Show that the exact thickness of the insulator is 363.75 millimeter. Now, the first thing we need to recognize here is that this is actually written in standard form, 485 times 10 to the minus 2. That's written in standard form. All right, as it is, there's no problem with it because I can put it in the calculator like that. But it's to understand the question. Let us focus only on the thickness of the cardboard box. All right, so let's just imagine that this is one cardboard box. All right, this is the thickness right here. We're not looking at the width and the length and the surface, just how thick the cardboard box is. What this is saying is that you have 75 sheets stacked up. All right, so this would be one sheet. You would put a second sheet there, which is of course of equal dimension, and you keep going until you have 75. Now, what am I going to do? Am I going to draw all 75 and add it up? No, because all the thickness is the same. To add them up, we simply multiply by the 75. Of course, you know that multiplication is simply repeated addition. So I'm going to have 75 multiplied by 485 times 10 to the minus 2. All right. And of course, all of this can go inside of my calculator at once. All of it can go in there. So let me see what happens. All right. So what we're going to do now is that we're going to put this inside of the calculator and see what happens. So I'm going to put in 75 multiplied by 485 times 10 raised to, and this is the raised to symbol right here, raised to the minus 2. All right, so we put all that in and we simply just press equal. All right, notice my calculator will give you as an improper fraction, which you have S to D, which means standard to decimal. So that's 363.75. Good, so let me put that in here. So this is 363.75. And of course, you have to remember that this is millimeter. All right, so it's a show that. So it's a QED, that which has been proven because it was a proof question. They ask you to prove that it's going to be equal to that. All right. Now, for part B, it says write the thickness of the insulation correct to two significant figures. All right. Now, for significant figures, we start counting from the left. All right. And of course, we know that all non-zero digits are significant. Since there's no zeros in this, then there's nothing to worry about. All right. So the first significant figure is 3, and the second significant figure is 6. Good, which means that I'm going to be rounding off to 2 positions then. All right. Now, after the 6, this is a key position, 6. You look at the number that comes after the 6, which is 3. The rule is that if it is 5 or above, we round the 6 up. If it is less than 5, we round down. When we say we round down, we don't mean that we round down the 6 to 5. It means that we leave it as it is. So correct the two significant figures, it would be 360. So of course, replace the other position by a 0. Now, whatever comes after the decimal point here, we don't need that any at all, all right? Because that's 0 point something. So we don't need those items after the decimal point. And in fact, if I were to put the decimal point here, I would have changed the value of the number in terms of significant figures, because once we input a decimal point, whatever comes after is going to be significant, all right? So the two significant figure is 360 millimeters. Don't forget the units, very important. All right. The third part says correct to 1 decimal place. Now let's go back up and look at the number. All right, the first decimal place is at the 10th position, and 7 is in the 10th position. We look at the number after the 7, which is 5, which means we're going to round the 7 up 1 place. So the 7 is going to become 8. So it's going to be 363.8. All right, so I'm just going to go down here, and I'm simply just going to input that. 363.8 millimeters. All right, and that would have been the end of that particular question. All right, the next question says in standard form. All right, this is what I'm going to do. What I'm going to do, just remind you of a number. I'm going to put it up here in the red. The answer was 363.75, right? So this is what I want in standard form. Now, in standard form, the number to the left of a decimal point must be a number from 1 to 9, all right? It must be a 1-digit number to the left of a decimal point from 1 to 9. So in this case, it means that I would have to move the point 1, 2 places so that the number to the left of the point is a number from 1 to 9. Good, so I would have to move 1, 2 places, all right? But of course, by moving in 2 places, it is equivalent to dividing by 100 or 10 to the second power. That is what you do when you move 2 places. Now, since I can't change the value of a number to reflect the same answer, I would have to say times 10 to the second power, which means that if you multiply by 10 to the second power, it would move it 2 places to the right. So it reflects the same number. So in standard form, it would be 3.6375 times 10 to the second power. And of course, put on a millimeter. Now, please understand what this is saying. The 10 to the second power would mean that I will be moving 2 places to the right. So the point would come back between the 3 and the 7, which means it's going to reflect the same value as what I had before. The value hasn't changed. That's the point of multiplying by 10 to the second power here. All right, and now standard form is very useful for writing large numbers, such as probably 1 million, right? Which is just really 1 times 10 to the 6th power. All right, very useful. Okay, taking this down a bit now. It says Marco is on a vacation in the Caribbean. He changes 4,500 Mexican pesos, all right? So pesos, that's a unit of currency in Mexico, to Eastern Caribbean dollars, ECD. He received 630 Eastern Caribbean dollars. Good. Complete the statement below about exchange rate. 1 Eastern Caribbean dollar is equal to dash Mexican. Okay. All right. So we're going to have to use a comparison here to work this out. So that we can start by saying, since we have ECD to Mexican, let me say that. So I can say, based on the question, they told us that 630 Eastern Caribbean dollars is equal to 4,500 Mexican pesos. All right. So you want to find out what 1 Eastern Caribbean dollar is. So you can say 1 ECD is equal to X, MXN. That's what we don't know. So we want to find, if we can find the value of X, we can find how much Mexican dollars 1 Eastern Caribbean dollar is equal to. Okay. Of course, using this comparison here, we're going to end up cross multiplying. All right. So we're going to go that times that and this times this. All right, let's go. So I'm going to have 1 times 4,500 is equal to 630. X is what we want. So of course, we're going to divide both sides by 630. Since we are multiplying the 630 by X. So therefore, this would give me, I'm going to have 4,500 divided by 630. Let me just quickly pull up my calculator here. All right, so I'm going to have 4,500 divided by 630, and this is equal to $7.14. Okay, so this would be $7.14. So $7.14. Remember, money can only have 2 decimal places, as 100 cents makes a dollar. Very important here. Move on to question 2 in the 2021 January resit paper. And it says factorize the following expression completely. Now, what does factorization mean again? It means that we have to write the expression as a product of factors. Factors means something that is common. Now, it's normally easy to start with the numbers. So what's the highest common factor of 12 and 4? The highest factor of 12 and 4 is 4. So we're going to take out the 4. M is not common, so we can ignore that. What about n squared? We have n squared, which is really n times n, and we have an n here. So only one of the n's is common. So I'm going to take out an n here. Now, in bracket, we can say 4 into 12 is going to be 3. You have n squared, you took out an n, so all you have left is n. 4 into 4 is 1. Now, of course, we don't need to put the 1 there because the fact that it's 1 means that we can just leave it as it is. We took out the n, and so on the outside, so all that will be left here is m, or 1m, all right? But we don't have to write a 1m because just seeing m there automatically means that the coefficient is 1. Because 1 is a multiplicative identity. All right? And that would have been your answer. You'd have gotten your 1 mark. All right, moving down to B part 1. It says, show that x over 1 minus x minus 4x is equal to x into 4x minus 3 all over 1 minus x. The first thing I must know is, what is this really? All right, here you have what we want to call a mixture. If you were thinking of it as a number, this would be like a fraction, this would be like a whole number, but this entire system is like a fraction. So what I want to do is to get this system on the left to look like a complete fraction. And since I'm subtracting, you know that I'm going to involve the LCM. So let me just rewrite this. So I have x over 1 minus x minus 4x. Now, of course, since we're dealing with a fraction, why not put the 4x over 1? So now it's like I'm subtracting a fraction from a fraction, which means that I'm going to have to go ahead with my LCM first of all. Now, what's the LCM of 1 minus x and 1? Of course, it's going to be 1 minus x. Now, 1 minus x into itself is 1, and I'm going to multiply by numerator, which is x by 1. So I'm going to have 1 times x. All right, 1 into anything is a thing. So you have 1 minus x times your numerator, which is 4x. So we have 4x, open bracket, 1 minus x. Now, normally, once you do that, we simply simplify the numerator. So 1 times x is x, minus 4x times 1 is minus 4x, minus 4x times minus x is going to give me a positive. Now, negative times negative is positive, 4x squared, all over 1 minus x. Looking for my like terms, x, 1x, and negative 4x. So if you have 1x and you subtract 4x, you're going to have a negative 3x plus 4x squared all over 1 minus x. Now notice what they did in the question. They have the 4x first. So probably you could rewrite it and say 4x squared minus 3x over 1 minus x. Of course, you notice that the numerator is written as a product of factors. So they factorize it. They took out what was common. Now, between 4x squared and negative 3x, the x is common. So I can take that out, which is going to leave me with a 4x minus 3. And of course, we put back the denominator, which is exactly what they wanted. So, we're going to say QED, which means that which has been proven, because it was actually a proof question. All right. Very good. Let's move down now. Hence, solve the equation. All right, now we need to understand the word hence. Normally, when you say hence, it means that you're using what you did above to work out what you have below. So instead of writing x over 1 minus x minus 4x, I'm going to use the expression that I proved that that was equivalent to. All right, so I'm going to say that this implies the same thing as saying x into 4x minus 3 all over 1 minus x equal to 0. Now, what is the first step in solving an equation like this? We must always remember that whenever we have denominators, it becomes very awkward to solve the equation, which means the first thing I want to do is to get rid of my denominator. What is my denominator doing? It's dividing. So to get rid of it, I have to reverse the process by multiplying by my denominator. All right, so we multiply both sides by 1 minus x. The beauty about this is that, all right, this is going to cancel out. So this takes this out. All right. Now, so I'm gonna have x into 4x minus 3 equals 0 multiplied by anything is 0. So that's complete. Now, why is it so useful now? Conceptually speaking, we know in math that if two things multiply to give you 0, one of them must be 0. So what this is saying is x times the bracket is equal to 0, which means either x is equal to 0 or the bracket, which is 4x minus 3 equal to 0. One of these must be 0. Okay, all right. So x equal to 0, that part is good and done with. So if 4x minus 3 is equal to 0, it means that we're going to have to solve this linear equation here. We can start by taking over the 3, and since it's negative, it becomes 4x equals 0 plus 3. So we do the opposite, right? So 4x is equal to 3. You have 4x, you want x. The 4 is multiplying the x, so we divide both sides by 4. So x is equal to 3 quarters. All right, but that's not the only value for x. Remember, over here, x was also equal to 0. So my concluding statement is therefore x equal to 0, or x is equal to 3 quarters. All right. Now, the critical term here was hence. All right, so you always have to notice what hence means. Use whatever you had or whatever you worked out to work the next question. So it's like a follow-up question. All right. All right, guys, we now move into question 2C on the January 2021 CXC past paper. And this is what C says. It says make V the subject of the formula in P equal the square root of 5 plus VT. All right, so the square root of all of this. Now, when it says make V the subject, what it means is that you should rearrange the formula so that you have V equal to something. All right, so let me just start by rewriting this. So I have P equal the square root of all of 5 plus VT. All right, so what do I do? Now, before I can remove anything around the V, of course, I'm going to have to get rid of the square root because the square root is over everything. Now, remember to transpose, we do the opposite of what we have. So the opposite of square root is square, which means I'm going to have to square both sides. So P square equal the square root of 5 plus VT all squared, all right? We square both sides. I'm going to have P square equal. But what is going to happen on the right is that the square will cancel the square root. So you have 5 plus VT. All right, what next? The 5 will go next because the VT is like a single term. So whatever is being added would have to go before I can move what is beside the V. All right, now it's a positive 5 and the 5 is being added to the VT. So I'm going to subtract it. So I'm going to have P squared minus 5 is equal to VT. All right, I don't have to subtract it on the right because naturally that is what I would have done. So once you subtract it from both sides, it's going to be on the left. If you want, you can show it, not a problem. So you could have said 5 minus 5 plus VT. 5 minus 5 is 0. Now we have P squared minus 5 equal to VT. You don't want VT, you want V by itself. The T is multiplying the V, so we can divide both sides by the T, which is the opposite of multiplication. So P squared minus 5 over T is equal to V. So therefore, V is equal to P squared minus 5 all over T. And that is how we make V the subject of the formula. A next term they could have used is to transpose for V. Same thing as making V the subject of the formula, right? So you have to look out for the terms that are synonymous in meaning. All right, let's take it down to question D. The distance needed to stop a car, D, so the common D here is representing the distance needed to stop the car, varies directly as the square of the speed S. Now, without even going any further, let us put that piece of information on the paper. Direct variation, you said D varies directly as S squared, where D is the distance, S is the speed at which it is traveling. A car traveling at 70 kilometers per hour requires a distance of 40 meters to make a stop. What distance is required to stop a car traveling at 80 kilometers per hour? All right, let's get right into it. If D varies as S squared, it means that D must be equal to some constant K times S squared. That's how direct variation works. Now, my job is to find K because K will never change, it's a constant. So we're going to use two known values. We are told that the speed, when the speed S is equal to 70, I'm not going to put on the unit, it's 70 kilometers per hour. The distance D required is equal to 40 meters. All right, so let's get right into it. So I'm going to replace D by 40, and I'm going to replace S by 70. So I'm going to have K times 70 squared. So I'm going to have 40 is equal to 70 squared, of course, is 4,900. And of course, you can put the K to the front. Now, since we want K, we're going to divide both sides by 4,900. 4,900. So K is equal to, of course, you can bring up your calculator here and use it to simplify it as furthest as possible. All right, so I'm going to have 40. I can use a fraction bar and put 4,900 as my denominator, equal. That's 2 over 245. So that's 2 over 245. So K is equal to 2 over 245. Now with this now, I can go back to the formula and say D is equal to 2 over 245 S squared. Of course, knowing that K is the only thing that remains throughout the entire process. So what distance is required to stop a car traveling at 80 kilometers per hour? So I'm going to have D equal, this is the speed, right? 80 kilometers per hour is the speed. So I'm going to put that in. So it's 2 over 245 multiplied by 80 squared. So D equal, of course, I'm not going to waste any time. I'm simply going to plug all this inside of my calculator. So I'm going to have 2 over 245, right? Space, open bracket. I'm going to put 80 in a bracket here, and I'm going to square that and press equal. All right, so that's what we get here. But we don't want this distance as an improper fraction, right? There are certain things that are better when they're placed as decimal, or you understand them better. So that's 52.24 meters, all right? So D equal to 52.24 meters. If you want to write a statement, you can write it. So therefore, the distance required to stop a car traveling at 80 kilometers per hour is 52.24 meters. If you want, you can go ahead and write that statement there.